Hello, my name is Xavier Ducroy.
My name is Michał Bendowski.
And I'm Jerome Daucher.
And let us tell you about the Android build system, especially a couple of features that you may not know about. So let me start with the performance checklist. That is all the things that you should make sure are in order when you're trying to improve your build times. So first of all, please make sure to use the daemon. That is already the case if you're building from Studio, but if for some reason you're building from the command line, like for example when you're trying to measure your build times, make sure you use the --daemon flag or enable it permanently using the Gradle properties. Secondly, please make sure to give the daemon enough memory. That is especially important when using the in-process dexing support that Zaf mentioned earlier today. You can use the org-gradle JVM args property to set the heap size that the daemon will use. On the other hand, if you find that your builds are making your computer unresponsive, you may want to limit the total number of threads that you will use. And you can use the Android thread pool size property to do that. Next, make sure you use the latest build tools. Specifically, 2302 is the latest one currently, and it's very important to use it because of the fixed dex merger that Zaf also mentioned earlier. Get an SSD. The sad truth is that building Android applications requires a lot of I/O operations, which means they actually run a lot faster on a fast drive. And lastly, make sure you don't use timestamps or commit numbers in your build files, or at least not for your debug builds. I'll come back to it later in the presentation, but it's really easy to make your builds non-incremental if things are too dynamic. OK, as mentioned, please try the dex in process flag. It's not enabled by default in 2.0, but it actually makes a huge difference. So please try it and let us know if it works for you. Also, consider having a dedicated development flavor with MinSDK version 21. The API level 21 introduced some features that we try to emulate at build time for older devices, like multi-dex, but also vector drawables. If the MinSDK is set to 21, then we have to do less at build time, which means the builds are faster. As we mentioned earlier, Studio will soon start to infer the MinSDK number based on the device you're targeting. But for now, having such a flavor is probably a good idea. OK, let's talk about testing now. I hope you already know that we support unit tests that execute locally on your development computer. But just to reiterate, there is a dedicated test source set where you can put your unit tests. There is a matching test compile configuration for all your test dependencies. And we support all the usual testing frameworks, although we recommend you use Unit 4. There's a separate session purely about testing right after this one, so I recommend you attend or watch the recording later. And let me just say that what we currently aim at supporting is to allow you to test your business logic. That is the part of your app that is not really specific to Android. Any Android code that you end up calling will throw exceptions, so you will have to refactor your code to either avoid it or mock those parts using a library like Mockito, for example. OK, when running unit tests from the command line, it's important to remember that the test task you may know from Gradle in Android projects is actually an anchor task that triggers the real testing tasks for each variant independently. So for example, that will trigger test release unit test and test debug unit test. Unless your business logic does something different depending on the variant, it's probably enough for you to just run Gradle test debug. OK, if you need to configure your test runs, like for example, you may want to increase the heap size for the test runner, you can use the test options unit test all block. That will apply the given configuration closure to all the variant-specific test tasks I mentioned earlier. And it's important to remember that these settings are not picked up by Studio currently. So this is only useful if you're invoking tests through Gradle, like for example in a continuous integration server. OK, another testing feature you may not know about are separate dedicated test projects, which allow you to keep your main code and your test code separately, which can be useful if you need this additional flexibility, and also if your code is already organized this way from the Eclipse days. The easiest way to get started with this feature is probably to copy the template from the Android testing templates repository. But let me give you a brief overview of what's involved. So the first step is to set the publish non-default flag on your main application project. And then you create a separate project that uses com-android test plugin. You specify which project you want to test and which variant you want to test. Most likely, you also want to specify the test instrumentation runner to be the one from test support library. Then you put your testing code in the main source set of your test project. That's something to remember. And currently, you still have to put an instrumentation tag in your test project manifest to specify the package of the application you want to test. Although we hope to get rid of this step soon. Okay, and once all of this setup is done, you can run the usual connected Android test task on your test project. Okay, another issue that shows up quite often when people write testing code is the dependency version conflict, which shows up when you're using the same library in your main and test code. So what exactly is the problem there? The problem is that at runtime, your main APK and your test APK share the same process and the same class path, which means they have to use the same version of every library, even if some of those libraries were pulled in as transitive dependencies of other libraries. Like a common example is support annotations in your main APK and an older version of support annotations that is pulled in by some of the test dependencies. So in this case, we choose to be very explicit about what's going on, and we force you to make a decision whether you want to change the version of the library that's used by your main APK or the version used by the test APK, which in theory may cause some of the libraries in this example runner to misbehave, although in practice, usually they don't. So the easiest way to solve this problem when you actually encounter it is to add another test dependency to your build.gradle file that explicitly depends on the same version of your library as your production code. OK, and now Zaf will tell you about native support.
OK, so starting with the new version of the plugin that we just released, we have better native support that we did before. At I/O, I mentioned a new plugin that we're working on, the model-based plugin, which uses new API in the Gradle build system. And part of those API is the ability to build native code. So without going through the makefile that we have right now in the NDK. So we made some additional progress, not a whole lot, but we're progressing. So the first thing to think about if you want to use it and try it is that we have different plugins, right? Normally it's CommAndroid application and CommAndroid library. And now we have, to replace them to use the new plugin API, you have to use CommAndroid model application and library. And then we have a third plugin, which is a plugin that only generates an SO. It doesn't generate anything specific Android. I mean, that SO is meant to work on Android, but it's just, there's no Android packaging around it. In all three cases, we directly use the Gradle APIs to build native code, but we configure them with the native toolchain coming from the NDK, so the ARM toolchain, the x86 toolchain, and all of that. So if you're using that plugin, the DSL is a little bit different, right? I think we mentioned that at I/O also, and there's some documentation here. You should go to that link and look at it. But basically, the biggest difference is that everything is under the model element. And then here you can see ndk.with. Again, the .with is something we want to get rid of at some point. You just define the module name, and then it will create a library with that name, and it will just take care of everything, basically. And then under that NDK element, you can also configure your C flag, your linker flag, and all of that. And something new, so some of that was already present in an earlier version. Something that was not present before was the ability to do intermodule dependencies. So we're now hooking up with, again, the new dependency management that this new Gradle plugin API brings. So you'll be able to do dependencies like that. As you can see, it's a very different DSL from before, where before you had the dependencies block as a root element. Here, it's under each element, each source set element. So it's a little bit different. And there's some option, right? You see that it's not compile or debug compile or anything. You just say what you want to depend on. But you can have some options on that, like if you want to do a static linkage, you would do project library and then linkage static, things like that. I recommend heavily that you look at the documentation for Gradle itself to see all the things, because it's an area that moves a lot, so you should definitely look at that. And then I want to talk about extending the Android plugin. We know a lot of you do a lot of things in there. Some of you even create plugins for other people to use. And we, every time we update the plugin, we see people using third-party plugin being broken up because the new version of our plugin is not compatible with some third-party plugin. And it's an area that we know is becoming more and more painful, and we want to solve the problem. It's not something that we're going to solve super quickly, but there's a few things to look at when you are doing that. So the first thing is we see a lot of plugins just trying to access task by name. The plugin wants to hook up in some task and then just do a get task by name, and that's just like a problem because we're not guaranteeing that those names are not going to change. This is not part of our official API. Even Studio does not use those names directly, right? Part of the information that's really exported by Gradle through the tooling API, part of that information contains the name of the task to call, so that in case we change it in the plugin, Studio doesn't need to be changed, it just reads the information from the model. So you should do the same, do not do that. Now, if you do that for your own build script, that's fine, you're not going, it's your problem to fix when we break you. But if you're publishing for other people to use, then you should be very aware of that. Another thing to be aware of really is how the after evaluate work. We see a lot of people who are very confused about that. After evaluate is just basically a callback that is called after the main DSL is passed and executed. And so we register one. As soon as you do apply plugin Android, we actually register one, and that's where we're going to create all of our tasks. And so if you try to manipulate tasks before, even though I said you shouldn't, but if you're doing it, then you should definitely do it in after evaluate. Because it's not working. But you can't actually manipulate other things in after evaluate than task. If you want to change build types or do some custom logic that's going to change product flavor, it's kind of too late because you can only, your own after evaluate happens after ours. And so it's too late. We already created the variants, we already created the task, and it's kind of late. So the right way really to access our tasks is through the variant API. So we have this DSL where you can do application variant .all, and then you get a closure, and that gives you access to the variant, its task, and all of that. Now the trick here is, I just said, hey, you need to access task in after evaluate, but that's not in after evaluate, that code. The trick here is that all. It's something specific to Gradle on the Gradle collection, and that basically it registers the closure you pass it, and it will apply that to all existing and future items in the collection. So by the time you call that, the collection will be empty, but every time we create a variant and its task and we add it to the collection, then your closure gets called. Okay, so what can you do with that object? You can do some basic things like creating the name, for example. Now that name is unique, so it's very useful if you want to create per variant task. You should use that name as part, like foo plus get name, and then you know that it's going to be unique for every variant. The dir name is a one or more segment of folders. Very useful to, again, store your custom task data. Do build dir / intermediate / foo / get dir name, and it's unique for all the different tasks. You can also get other information like the application ID. That's computed, it's a merge of the product flavor and the suffix in the build type and things like that. You can also get access to the build types, product flavor. Those are read-only. We've seen people change them. And so a few releases ago, we actually now give you a read-only version of them. You should not change them. They are shared across all the different variants. So if you're trying to change them, you need to change them before you access the variant API. You need to change that in the regular DSL. We also give you access to the task name. So that's where you want to go and query the task rather than doing it by name. And we know that a lot of you are trying to get those tasks in order to do things like inserting steps in between two different tasks and things like that. And you have to be very careful about what you're doing there, right? I'll go back in a little bit about the task API, but there's some things that you want to do. For example, if you're trying to generate what we consider to be source code, whether that's Java source code or Android resources, you shouldn't try to go in and hook that manually yourself. We have some entry point in the variant API called register Java generating task. There's actually some parameter to that, like your task. And you should basically have your plugin add a new source folder to the regular Java source folder list, right? It's multiple source folder, not just one. So you can add a new one to that collection, and then have your task just write to that, register your task with that, and then we'll call it what it needs to be called. Studio will know about it. And then it will work end-to-end rather than having you kind of trying to find the task manually and hooking things up together. That's, you definitely don't want to go into the Java C task and try to give it additional source folder there, right? Just tell us what the source folder is, give us your task, and then we'll take care of things for you. Now, if you look at some of the tasks, we don't really have a proper API. So you may have looked at our source code and seen something like that. It's like, hey, here's some public stuff and here's some private stuff. Don't use the private stuff. It will break. We will break you. That's why it says private. The public stuff may break anyway, because we haven't been very good about really considering that a public API. It's definitely something we want to do in the future. And we know that a lot of people want to inject stuff between two particular steps, and that's between Java-C and DX, right? We know about that. And so we've been looking at ways of solving that problem rather than having you go and look at the source code and see, hey, what does the DX task do, and how do I inject it additional jars or whatever? So if you look at it here, that's a default project. You create it just goes straight from Java-C to DX, and that's easy. But in reality, well, you have additional optional steps already. Jacoco, which could or could not run, then Progard, which could or could not run, and then we just added instant run. So imagine you trying to add, a couple of other, bytecode manipulation thing, and trying to have to hook all of that together. Hey, what if I'm plugin A and is plugin B so that I can hook myself separately? So we just wanted to fix all of that, right? So starting in 1.5, actually, we introduced a transform API that's, the goal is to solve that problem. So it's just a pipeline of transforms. It's not a pipeline. It's a very static pipeline. It's mostly helping us set up those different optional steps. We want the API to be very simple in terms of adding a new transform. And so it's not something that you can manipulate after the fact. The API doesn't talk at all about tasks. We don't want you to think about manipulating tasks, handling the dependencies between them. All you have to tell us is, hey, what do you want to transform, and things like that. We take care of the rest for you. We do support different types. So for now, on the public API, we support Java bytecode classes and non-Android resources, right? Things that you would find in a jar. And it's important because, for example, Progard manipulates those. And we also support DexFile, though it's not available through the public API. We might change that a little bit in the future, but for now, that's not the case. We also, the way we package and merge resource libraries is actually also going through that pipeline. And then we support different scopes. So, for example, Jacoco, we only run it on the project scope, right? Only the main app project module. Instant Run also right now on that project, but we'll add the submodule to it, so you'll be able to say, hey, I want to run on those two scopes. Progard will run on all of the scopes because it really want to look at all the source code of all of it. So to implement a transform, we have an abstract class called transform. There's a few methods to implement. Get name, it has to be unique. We actually use that to generate the task name. Get input type is what you want to transform, classes or dex. So content type is actually an interface, but there's a separate enum default content type that contains the type you can change because we have a private enum for the internal only types. Scope is an enum, and get scope will give you the scope you want to manipulate. Is incremental, whether your task can or cannot be incremental. If you can't, really tell us false, and we'll optimize some things, or we won't do some work when we call you. And then finally, the transform method. So you get a context to get some information about Gradle, not the task, but a few things. You get your inputs. You get some reference inputs, right? When we run Progard, if it's a test app that's testing something, it needs to have access to the tested code. And so Gradle, the Gradle transform actually asks part of the scope that it asks. There's a get reference scope that's not an abstract method, but you can implement it anyway, and you can say there's a scope that's called tested code. So you can ask for that too to get access to it. You're not supposed to touch it, you're not supposed to write it, but you can get access to it to read it. And then transform output provider allows you to create different type of outputs, and then whether that particular run is incremental or not. And there's some additional features on it, like secondary file inputs, secondary file output. For example, Progard outputs its mapping file as a secondary output, things like that. I encourage you to look at the Java doc. So to use it, just do a dependency on the transform API artifact, either in your own plugin or directly in your build script. And then, there's a global, for now, entry point in the DSL, register transform, and then give us the instance. If you give an instance like that, it's a single instance that will be used for all the variants. So make it stateless. But it's fairly easy to do. So all of those are using the transform right now since 1.5. As I mentioned, Jacoco, ProgArt, the new shrinker, Instant Run, Dex. And because Dex is now a transform, we kind of like remove the regular Dex task. So if you're currently trying to use accessing the Dex task, you're going to have a problem, and we want to fix that. It's not technically gone, but it will throw an exception. So in terms of order, this is the order in which we will run the transform. And there's no way right now to change that. It's really, in terms of the third-party one, there could be more than one, but it's really first come, first serve, right? It's like as you apply custom plugins, that will drive the order of those transforms. So we have some limitations. So as I mentioned, they're global, they're not per variant, but we do want to fix that, hopefully for 2.0, for the final version. And you cannot change the order through the API, and it's something we need to figure out because there's some issues, right? Like ProgArt will merge all the scope together into a single jar. I talked about that in my other talk about how it generates now a single jar file. The new shrinker doesn't. The new shrinker outputs one, for every scope that it reads, it outputs a single output. So if you have something that needs to read just one scope and something that merge all the scope together, then the order will fail. So we need to solve that somehow in the API at some point. OK, so that's the transform API. Again, the doc is there, the Java doc. Go look at it. Give us feedback. The API is mapped as beta right now because we want to be able to change it. Please use it and let us know if you run into trouble. OK, I want to go very quickly through inspecting your builds. We know that this is something that some people have a lot of issues. They don't really understand what's going on with their build. And so there's actually a few tasks in Gradle that allow you to do that. The dependencies one is a standard task. It's not provided by our plugin. It gives you your actual dependencies. So you can see all the transitive dependencies and all of that. It has some interesting features like showing you which one gets promoted to a new version just because you have two versions of it in your graph and one is higher than the other one. Well, in the path that lower, you will still see that, even though it says 2301, it's actually using 2311 because somewhere else you do depend on 2311. And then, if you have multiple versions of the same dependency in your graph, so it will show that to you. So for example, here support v4 is used twice. And so the first time it shows you its transitive dependencies. The second time there's a small asterisk saying, hey, you've seen that before. And it won't show you the transitive dependencies. So that's what that little asterisk means. Now, this will show you per configuration object. And if you build your debug variant, for example, we actually take the compile configuration. We take the debug compile configuration. And we kind of put them together and resolve them at one, right? So even though here it's the compile configuration and we're resolving to support annotation 2311, if in debug compile I'm using 24, then ultimately it will use 24. So you really want to look at it at the variant level, like globally. And so we have this Android dependencies task that does just that. It's at the global, that debug here is actually a full variant. So you can use that. We have one for source set. So I know that sometimes developers are adding source set and not sure whether or not it's actually adding the source set and not knowing which are the folders. Just look at it. And then for each, you see the source set, you see the actual compile configuration associated with it. You see the actual source set object that you can manipulate in your build.gradle, so it's very convenient. And then finally, we have the report signing task. If you're configuring your signing through it, you can just do that report. If you provide with the password somehow, then we can show the fingerprint that can be useful and things like that. All right, and with that,
thank you.
Instant Run.
All right, so let's talk a little bit about Instant Run. I'm not going to give a very deep technical description on how it works, but I think it's important that you understand some of its concepts because it may impact you during your iterative development cycles. So what happened with Instant Run is that you start with a class that you've loaded inside your virtual machine, and that class has many fields and a couple of methods. It's loaded, and as your application is running, most likely you start having instances of that class around, and this has been created. At that point, your application is running, but you realize that it's not running the way you want it. So you go back to the IDE, and you start writing code to change the behavior of that particular class. Once you hit the button, Instant Run, we're going to be compiling just this particular class, we're going to be dexing just this particular class, and we're going to be delivering just these particular classes to the runtime. So that's why it's super fast. So at the runtime level, we're going to create a new class loader. And in that class loader, we're going to load what we call the override class. So first thing to realize is that we never actually reload the full class. The full class has only been loaded once, and it will be always loaded once, never reloaded. Instead, we will be loading as many override classes as we want because we use a new class loader. If you continue writing more code on this foo class, we'll just ditch the previous version of the class loader with this override version, and we'll have a new one coming in place replacing the foo. So once we have set up this class loader, we loaded the foo override inside it. As you can see, all the methods of the original class have been moved to static methods on the override, and the new code is actually implemented within these methods. Now we just have to do one more thing. It's to redirect. So we redirect from the original foo class every method implementation to the new one. Okay, so that's how it works at the very high level. Very simplistic demonstration, but very things to understand is this concept of this original class which never changes and the override class which we can change many times. One of the things which is important again is that if you create more instances of this foo class, we're going to be using the original class. So the instances will all be coming from the exact same class. And it's particularly important if you store them in a collection. You want them to be of the same type, right? So again, remember that the foo class will remain, and all of the instances that will ever be created will be from the original class. What does that mean? First of all, the override class will appear in stack traces. Right? If you generate a stack trace, let's say a null pointer exception, which is my own favorite bug, you will see the override class in your stack traces. So you should not be surprised to see these classes appearing. We could have potentially removed them, but we decided that it's probably better to not try to mess too much with the stack tracing and leave it. But you must be aware that it may appear. The more subtle thing that may happen is that new method calls only generate, the new code is only invoked through new method calls. That means that if you are running a particular method and you have a while loop or a for loop inside it, and you change that class implementation, it's not going to change the thread which is actually running the current version of the code, right? Only when somebody else is going to call that method will the new code kick in. So that's particularly tricky when you think about recursive calls. So a recursive call, say, is going to call itself 100 times. The first 10 times it calls itself, it's the old version of the class. Now suddenly you're going to swap the class, and it's going to start calling the method again. And because it's a new call of a method, it's going to kick in into the new implementation you just provided. So it's going to call itself 90 times with this new code. But then as it will come back and unwind the tail of your recursive calls, it's going to come back to the original method implementation. So you can see here, this is getting into really muddy territory, and you should be aware that you could have surprising results when you start mixing, obviously, the implementations. The best way when you think this kind of stuff happening is just to force a cold restart, which is basically you stop the application and you restart it. I don't expect this is going to happen very often because there's not that many recursive calls or stuff like that happening in Android world, but something you should be aware of. Again, I already touched it. Methods are replaced, not really classes are reloaded, right? We do not reload classes. I know it sounds like we are reloading classes, but we really are not. We are replacing method implementations. So classes are loaded once. What does that mean? That means the class initializer is only run once. And if you change your class initializer, we will flag this as an incompatible change. As you know by now, the instant run technology is only supporting basically changing method implementations. But if you change a field or if you add or remove a method, we will actually restart the application for you. Same thing for the class initializer. If it changes, we will restart the application because it's an incompatible change. Static variables are not really initialized either. So if you have a class and you have some static variables which are not final, and you started changing their values through the code, suddenly you hot swap that particular class version to a new version, even if the code that was actually initializing these values in run, it's not going to change the values of those static fields. All right, so you should not expect things to be reinitialized. Again, the class has already been loaded. It's just going to continue living its life. Same thing for instances. You may have already created instances of the class that you are going to update, and we are not like destroying those instances or trying to extract their fields values and putting them into some new objects. No, those instances stays around, and the instance fields remain at the same values that your application has already set them. That's also very true, of course, for singleton objects. Again, that's kind of a situation where you could expect, or you possibly would expect, that because it's a singleton object, somehow we're going to recreate it with the new version of the class. No, we are not. It's going to be the same singleton object. The only difference is that all of its method implementation will be redirected to the new code. So if you are initializing the fields of your selection of your singleton object a certain way, don't expect it to be reset just because you change the constructor in the new version of the class. Sure, the constructor would set the fields to the new values if it was to be executed, but because it's a singleton, it's not going to be executed. Therefore, you're going to get the old fields values. So it's important to understand all of this. At the end of the day, you should not worry too much about it, but it's possible that sometimes your application does not really behave the way you think it should go, and that's most likely because maybe the code you've just modified does not work well with the state of the application it's in. You should just restart in such cases. All right. We also want to talk a little bit about recipes. So these are important things that we would like to raise awareness about. And the first one is an old way of generating multi-APKs, which are ABI specifics. So in the past, when you wanted to reduce the size of your APKs, one of the tricks was to say, I want to have an APK which is specific to a particular ABI, and I'm only going to be supporting the 86 in this particular case, where I'm going to be shipping only the .so file that are running for this particular ABI. And in this example, you could also specify that you wanted a full, which would have the ability to run on any possible devices, irrespective of its particular ABI. However, it will be obviously a very big APK. So in the newer version, you should not use product flavors for that. You should use product flavors to define your applications and not how we package the resulting APK. In the new way of doing things is by using these new split declarations inside your model, inside the DSL. And the way to do that is by either using ABI, densities, or language, depending on which type of APK you'd like. And what it's going to generate in this particular case is 4 APKs. 3 APKs will be specific to a particular ABI, 86, ARM, MIPS, and one will be the universal one again, which contains all the possible ABI SO files. This way, you will get a much smaller APK each time, and you do not pollute your product declaration, the product flavor declaration, as you had to do before. Next one is the resource shrinker. So for many years, we've had the ability to shrink the code using ProgAd. And that's particularly useful when you import a library and you may be only using 5% of the library facilities. You don't want to ship all the code associated with that library. So you use ProgAd and you kind of strip all the code that you're not using. However, it was not stripping the resources associated with that particular code that is being stripped. So we now have the ability to have a resource shrinker that you can piggyback on the actual ProgAd file to figure out what are the classes that are really necessary for the application and which are not necessary, and make educated decisions about whether or not some resources are necessary. So when you use ProgAd to release your application, you should most likely always shrink your resources, and it's going to result in a much smaller APK size, which is great for users. Next one, I think, is back to Michael. Yep. Thank you.
Thank you. Okay, this one most of you probably already figured out, but let me just talk about it real quick. If your project has multiple sub-projects, it's a very good idea to share the same versions of dependencies and your SDK levels and tools version between all those projects. So the way we recommend you do it is using the Gradle extensions mechanism. That is, use the ext block in your root top-level Gradle file, and then inside this block, you can create properties to hold the constants you want to share. You may want to use the Groovy syntax for defining maps, like I did here for depths. And then you can reference those values using the root project prefix in all your other build files. Okay, another tricky part that sometimes people are surprised about is the scoping rules in build files. So as much as Groovy scoping has its edge cases, the basics are the same as you know from Java. So the dependencies block in the current plugin, as I've mentioned, things are actually a bit different in the new plugin. But in the current plugin, the dependencies block is a top-level property of the overall project context. So the fact that you reference it from some nested call deep within the Android block doesn't really change the meaning of the call. So that even if you would expect this code on the screen to add a dependency only to the given flavor, the free flavor, it doesn't actually do that. What you should be doing instead is put the dependencies block at the very bottom, at the top level, to make it clear what's going on. And if you want to add the dependency only to a given flavor, you should use the specific configuration that we have for this flavor. OK, let's talk about flavors in general. I hope you already know that flavors are a good way for you to create different variants of your application other than build types. In the next talk, Jose may actually talk about how you can use flavors for testing. But what should you do if you want to differentiate your app in more way than one? So let's imagine you have a free version of your app and a premium version, but you also want to sell it in blue and red flavors because you believe that will actually increase the sales. So instead of creating all the combinations manually, what we suggest you do is use the built-in support for flavor dimensions that we have in the Android plugin. So you can define well-named dimensions like price and color in this case. Then for every flavor, you specify which dimension this flavor belongs to. And the additional advantage of doing it this way is that you get dedicated source sets for example, red-only resources and blue-only resources, and premium-only code that is shared between the premium red and premium blue variants. So that's very convenient. OK, but what happens if not all the combinations of build types and flavors make sense? At the start of the presentation, I mentioned a development-only flavor. It probably doesn't make much sense to ever combine it with a release build type, because we never really want to distribute the development variant. So what we can do is use the variant filter method on the Android block, which allows you to register a closure. And the closure will be called for every about to be created variant and will be passed a variant filter object. You can use this object to inspect the build types and the flavors of the variant in question. And you can also set the ignore flag on it to indicate that this particular combination should be skipped. So you can think of the variant filter object of an instance of such an interface when there's one setter for the ignore flag, and there are getters for build types, flavors, and the shared settings from the default config, shared between all the variants. Right, let's talk about vector drawables, which is a feature we've added in 1.5. So what vector drawable support does at build time is whenever we find an Android vector drawable XML file in your drawables directory, we will rename this file to be within the NEDPI v21 directory. And we will also generate a number of PNG images, one for each density, for all the devices to pick up. You can control the set of densities that we generate. So if you don't want to package low DPI images in your APK, you can choose to do so. This setting is per flavor, so you can have a default set of densities in default config and then override it for a particular flavor. And you can also set the set of generated densities to an empty list set, which will disable the feature altogether. OK, lastly, since we have some more time left, let's just mention real quick build config. Build config is a class that we generate at build time for each and every variant. You can use it to inspect which build type and flavor were used to actually compile your given variant. You can use it to, at runtime, execute different code depending on the given flavor. So for example, you may want to write an if statement that checks if flavor is premium. And you can also add additional fields to the build config class by using the build config field method on build types, but also flavors. So in this case, if I really want to hardcode the build date into my build config class, I can do it. As I mentioned at the start, I will only do it for the release builds. So in the release builds, I'll put a string field called build date in my class. The values are pasted as is into the build config Java source file, which means you have to make sure the quotes are in place. And here I assume there is a format time function somewhere in the build script. So that will allow me to actually reference the build date in my release builds. For debug builds, I want to hard code a constant value, so that my builds are actually up to date. You can imagine that if format time actually changed every second, my builds would never be up to date, because every time I run Gradle, build config source would be different, which means I would have to compile it, which means I would have to redex your entire application every time just because this value changed, which is why we recommend you do this kind of stuff only for release builds, never debug builds. And if you need to, you can also define the res values, which would do the same thing, but it would put the values in the as a value resource, as a string resource. OK, yeah, that's it. And that's all we have for you today. Let's go into the Q&A session.
There's 2 mics in the back. If you want to ask a question, please go there. We have time probably for just a handful of them. Yep.
I have a question about shrink resources. I see my PNG files are not in the build APK, but the IDs are still in the r.java file, and it's causing weird crashes on Samsung devices. And I saw a solution was to replace those PNG files with like 1 pixel resource. So can you say something about that, about shrink resources?
So the way the shrinker works is that it looks for code that uses those IDs, right? But it is not removing the R class. I would be surprised why on some devices they actually, like if your code does not reference that ID, and we're trying to be very conservative. There's some cases where we don't remove stuff that could be removed because we're not sure. It's difficult, right? We just look at the bytecode. We don't know the actual call. We just say, hey, 42. OK, maybe that's a resource ID. So when we're sure that that ID is not available anywhere, we remove it. So I'm not sure why that would still be called on some device, you said?
No, me neither. But there's a bug report for that, so.
I seem to remember that Samsung was pre-caching any ID you would find in the application, something like that.
Okay. Yeah, I don't have a good solution for you in that case.
I think the good solution for now is shrink resources false.
Yeah. I mean, we could also rewrite the R class to remove things. The thing also that we're doing is we're just removing the assets, right? We are not actually removing them from the resource table. So it's
right, so I thought there was a mode where we would put the smallest possible PNG to replace the actual one, so that Samsung would be happy, would find it. So, but it still doesn't work.
I don't believe that thing is happening right now. So
okay, we should talk about that.
We should talk about that because I thought it was already
the solution. Okay.
Is there any the development on native dependencies that would actually also bundle headers in the case of native dependencies that would be deployed to MVN repository, for example?
No, I actually don't know. That's probably more a question for Gradle, right? Like if you have a module that only outputs a .so, and I know you can have headers because the intermodule dependency supports that at the Gradle level, but I don't know what happened if you try to publish that to any sort of repository. You would have to check with Gradle itself. Okay. I've seen hands somewhere, so.
Is it possible to debug why Instant Run decided not to do an Instant Run on a particular instance? Like if you changed a field, it can tell you like it's because you changed this field?
Yes, if you if you add a field and the Instant Run has decided that it needs to restart, is that what you ask?
Yeah, but like I was just wondering, is there some sort of logging that'll tell you like
yes,
this is why?
The IDE will tell you application restarted because you added a field, or because the static initializer has changed, or because we added a method. It will tell you.
Is that the balloon, or is that?
It's a balloon. When you run, there will be a balloon that tells you restarted because of.
Yeah.
Is there a way when you build a debug build to make it have a different package name as a release build?
Yes. In build type, there's something called application ID suffix. So if you do any suffix, and it appends that to your regular package name. So if you put .debug, then the debug build will contain that new package name, and you can install it side by side with the release package.
If I have like custom views in XML files, do those get upgraded?
No, then you would have to make a copy of that particular layout, put it in the source debug res folder, so that you would have a custom version of that. We know that it's something that people want to have placeholder in those and to replace them on the fly. It's something we will probably do at some point.
Okay, thank you.
I think we're running out of time. We will be at the office hours all afternoon, so feel free to come and talk to us, and fireside chat also this afternoon if you want to ask questions. Thank you.